Hi, and welcome to Dark Principles for DarkBASIC Professional Turbo TT3D. The good news is that the 15-minute video limit has been removed from my YouTube account for the next month, so I thought I'd take the opportunity to produce a single long video tutorial rather than produce multiple parts, which is my usual style. This tutorial is going to feature my first complete 3D tutorial. This game I've dubbed Turbo TT3D, which stands for Turbo Table Tennis 3D, which is based on the Pong concept. For those of you who've already been through my 2D tutorial, this will produce a more attractive program, complete with lighting, shadows, and of course primitives. The primitives can be substituted at any time with proper 3D models, or you can simply retexture them. You can also add shader effects or anything else you feel you need to. But I'll leave the customization up to you. As usual, I'm assuming that you know the basics of DarkBASIC Professional's command set. If you don't understand what a command does, please look under the help file. You can do this by simply clicking on the command and pressing F1 on your keyboard. DarkBASIC Professional will then produce a help file entry which will tell you how it's made. I'm assuming you also understand basic concepts such as variable types, setting up types, if statements and case choice making, or anything else. If you don't understand these concepts or you find it's all going well above your head, then please purchase my Dark Principles for DarkBASIC Professional DVD tutorial kit, which has more than 7.5 hours of fundamentals covering all the basics you absolutely need to know. This is on sale at Amazon.com. You can buy them as a 3-disc set, or you can buy each volume one at a time. Okay, now we're in the DarkBASIC Professional editor. I'm going to basically set up my software environment, and I'm going to do this by first clicking on File, New and a Project. I'm going to give it a name of TTT3D and click on OK. And of course this will then set up a proper project for me. Now unusually, what I don't usually do on these things is create multiple source code files. However, this is quite a large project with quite a lot to organize, so I'm going to break with my usual tradition and I'm going to create several source code files in addition to the primary one. One will be set up for environmental setup. That's things like variables, data types, and general startup code, things like sync on, etc. And I'm going to set those up as subroutines. To do this, you click on this little button down here, which is called Solution Explorer. You can expand it here, and this gives you a list of your source code files. To add a new source code file, simply click on the Add New File, and simply type in the name of the file. So I'm going to call it Enviro, short for environment. And as you can see, it's now added to this list, and you've got a new tab up here as well with a new area to add in your commands and data. And I'm also going to add a second one called Functions, and that of course will appear in the same way. So naturally all the functions will go in here, any subroutines and general program setup will go into Enviro, and all the main loop code, the main program code, will go into the primary file. Now what I'm going to do is just give you the basic layout of the program and explain what each section does, and then we'll go into the actual programming of it. So we're going to start off with our program with go sub data underscore setup and go sub environment. And then we're going to type in plyr.lives equals 3. This naturally will be the number of lives that we have. ai.lives equals 3. ai.trigger equals 0. Now we haven't set up any of these commands yet, sorry, any of these data types yet, but of course we'll get to this shortly. The AI trigger will basically set how sensitive the AI is when it starts responding to the ball. If you leave it at the full length or full activation, which is about plus 400, then it's going to be impossible to beat because it will be constantly tracking the ball. Whereas if you set it to minus 300 or minus 400, then it's going to be relatively easy to beat because the AI isn't going to respond to the ball until it's quite close to the pad. But you'll see what I'll talk about, what I'm talking about as we get to that section. I'm going to create a new function called make objects. I could have called this setup scene or something, but make objects will do. And we're going to type in set reset, which is basically going to reset all the data and movement data for our pads and ball, so we can continue with the scene. And now we're going to progress onto the do loop. So do and sync and loop. And between there, we're just going to type in 4 functions, which is ball, player control. Remember, these are case sensitive, so you need to watch your typing. I make many mistakes while I'm narrating as well. AI control and screen text. Again, if you don't understand functions and how I can put dots in my variables and things, then you need to go off and get my DVD tutorial set because you're not really advanced enough to continue with the tutorial. Anyway, this is the basic program layout. So we've got go sub data setup. This will set up all our variables, our data types, and it will set up our general environmental data such as the position of the camera, sync commands, set random variables on, that kind of thing. Player lives, self-explanatory. Now I've set up player lives and AI lives separately for the simple reason that if you want to make it harder, you can give the player less lives than the AI, or if you want to make it easier, you can give the AI less lives than the player, and this gives you a little bit more flexibility. AI again will basically set when the AI triggers to the ball. So if you imagine the pad on one side of the screen and a zone around the pad extending towards the player, then whenever the ball enters that zone, the AI starts responding. However, when it passes out of that zone, it doesn't respond. Now, what's quite important to remember with 3D, for anyone who did my 2D tutorial, is that they go into negative numbers. So the center of the screen, as I've set up this program, will basically have plus 400 on one side towards the player and minus 400 towards the AI. So by setting it to 0, we're actually setting it to respond as the ball passes into the AI active zone. So basically it'll only respond when the ball passes into its half of the field. Again, I'll go into more detail of this as I type in the coding and you can see what's going on. So anyway, this is the basic program layout. Ball is basically going to... I'm sorry, I've skipped ahead a bit there. Make objects is going to make the scene. This basically means that it's going to make the ground, it's going to make the balls, it's going to make the pad, and it's going to set up all the objects in the scene that are going to be invisible that allow us to detect collision. And that's basically what make objects is going to do. Then set reset is just going to reset all the data. This is going to be used several times throughout the program. Anytime we want a new set where we're restarting the game or match or whatever, then we just call set reset and it resets the game. Now ball, as I was about to describe earlier, handles all the collision data and the positional data. This means that if the ball impacts the wall ball on either side of the player, or it impacts the pads, then different events are going to trigger as a result of that, and all that is contained within the ball function. Player control is self-explanatory. The basic controls for this is simply going to be the up and down arrow keys, so there's not a great deal to do there, but that's all contained within that, because again, by modularizing our program like this, it allows us to add additional things as well. For instance, I might want to add gamepad support, in which case all I've got to do, rather than hunting through hundreds of lines of code, is simply go to the player control function and type in everything I want there. AI control is self-explanatory. That's basically going to tell the program whether or not it's allowed to start tracking the ball yet, and then it's going to describe how the computer goes about tracking the ball. And I'm going to set up speed limitations and all sorts of things just to keep the game fair and give the player a chance. Otherwise, you're just going to have a perfect AI that's constantly tracking the ball that no one can defeat, and what's the fun in that? Screen text is diagnostic data. This is basically going to be position of the ball, what flag trigger is set, and all sorts of other diagnostic data. So if anything goes wrong with the program as you're typing it in, because there's going to be a lot of code here, mistakes will happen, probably on my end, to be honest, because I'm retyping all this off another screen over there. But if I make any mistakes or anyone else makes mistakes, then this diagnostic data will basically allow us to see what's going on in the program, and with any luck we will quickly and easily be able to see where the error is occurring, then fix it and carry on as usual. So this is the main program loop, and I'm just going to put that as loop because it pleases me aesthetically. So now we describe the main program. We will start off by going into the enviro.dva file, and we will set up everything there, and then we will go into the functions, and we will test each function as we go along, and hopefully do a proper job of this and turn this basic source code under ttt3d.dba into a fully working game. Okay, so now we know what we're actually going to do and what we're about. We're going to go into the enviro.dba file, which is a blank file, and we're going to start typing in our go sub functions, or our subroutines. And we're going to start off with data setup, so it's in order. And remember, you should always type in return at the end of a subroutine. And we're going to create our second one, which is going to be, excuse me while I scroll down the screen, which is going to be environment, of course. So in environment, I'll just put a colon after it, and that makes it a label. And we're going to type in return, and those are basically going to be our two subroutines for the whole program. So we're going to, first of all, we're going to set up our data. And I've got it on another screen over here, so I can organize it properly. And we're going to set up our first data type, which is going to be type and ob data, and end type, which of course ends the type. And then between there we're going to set up several data types. If you don't know what this is, again, please go and get my DVD tutorials. I explain all that there. So ID as integer, X as float, Y as float, and Z as float. And we're going to set X speed as a float as well, and Y speed as a float, and we're going to set lives as an integer. I could set it as a word or something smaller, but that'll do. So lives as an integer, and trigger as an integer. And we're going to set up flag X as an integer as well, and We're then going to, sorry, just a moment. So I put a lot of commentary in that one, so I wasn't sure where I'd put it. So the next one, of course, is flag Y. And finally, we're going to end with flag. So I'll just set that as an integer as well. And flag as integer as well. So basically floats and integers. I could optimize these a bit, but this will do for such a simple program. Next we're going to set up our global variables. So global ball as ob data, global AI as ob data. In fact, I can copy and paste that to save myself a bit of time. So global PLYR, short for player, as ob data. Doesn't really matter if that's a big L, but it's nice to type it in right. Global TB as ob data. Global BB as ob data. And the final two we need to set up is going to be global AIB as ob data and global PLYR B as ob data. Now, ball is self-explanatory, AI is self-explanatory, PLYR is self-explanatory, TB stands for top boundary, BB stands for bottom boundary, AIB stands for AI boundary, and player B stands for player boundary. And what this basically means is, if you imagine a square, you've got top, bottom, you've got left and right. Now the player is going to be on the right hand side and the AI is on the left hand side. So basically any time the ball impacts on the AIB, which is the left hand side, this will trigger some kind of response and the data will be handled here. Anytime it hits the right hand side, again it will hit the wall and all the data will be handled there. BB will handle any impacts on the top section, and TB will, and BB will handle anything on the bottom section. Player will handle any data to do with player related issues, which is going to be positional data, ID, that kind of thing. AI is pretty much going to be the same as player ID, except it's going to have the additional boundary, or rather zone, active zone, I should call it, active zone trigger area to worry about. And of course ball is going to be positional data, speed, and other things as well. This is where mainly the flag X and Y stuff comes into the decision making process. So it's all a bit mysterious right now, but I promise you it all serves a definite purpose. And that's about it for the data setup. So now we're going to go to our environmental area, and we're going to type in the all too familiar sync on, sync rate 60, and backdrop on, color backdrop 0, auto cam off, and randomize timer. And we're going to position our camera as well, so move camera 0, -550, and we're going to set global global collision on. Yep, I did type it in right. And that's basically it for our environmental. We don't need to return to this again. It's all done and dusted. Oh, I really should say, always remember to save. Otherwise, when something goes wrong, as it usually does, you're going to have serious problems. Okay, so now that we've set up our environment, the next thing we're going to do is disable all of these functions, because we will be building them one at a time and testing them one at a time as well. So so what we're going to do is we're going to start off with the first function, which is make objects. We can uncomment that one. Now, the way I commented it was to use the I'm not sure what the key is called actually, but it's located between escape and the tab key. So don't go putting in one of those because it won't work. You need to put in one of those instead, or you can just type in rem if you can't find that key. So that just stands for remark. So we'll comment that out again. And then we'll go to our functions area and we'll create a new function called function make objects. Now, I could have called this make scene or set scene or whatever, but this was as good a name as any at the time. Press return, and the IDE, or at least a new one does, also end functions it for you, which is quite handy. And what we're going to do is we're going to start off by creating a light, or rather setting a light up as a spotlight rather than an omnidirectional light, which is what we got so far. So we're going to click on, sorry, going to type in, not click on, set spot light 0, 2, 3. And if you're not sure what this does, again, you've always got the option of going to the command like that, pressing F1. And if it doesn't turn up the first time, I've had this problem before, press F1 again and it will take you directly to the command. So a little bit of a glitch in the help file system there, but once the help file is open, it quite happily goes to that location, and you can do it for absolutely any command and it will take you to that location in the help file. I don't need it because I know what I'm doing, but if you do, it's located there. So just type in set spotlight 0, 2, 3. And then we're going to type in position light 0, 0, minus 200, minus 250. And we're going to point light at 0, 0, 0, 0. So it's literally pointing in the center of space. And next we're going to create a floor. So we're going to type in make object plane 1, 801, 603, 1. Now I've experimented a lot with these dimensions, and with the position of the camera and everything, I find this to be the most attractive, even if the numbers are slightly odd. Next we're going to color our floor green. So color object 1, RGB, open bracket 0, 255, 0, and close bracket, and this will now give us a nice green scene. Now, because we've basically enabled the make objects, which is now blue, you'll notice, rather than grey or black, we can test our scene at any time simply by compiling the program to see if we're getting the desired result. So if we press F5, as you can see, we now have a nice plane in the middle of our screen that should be green. So basically we have, if I compile that again to show you, sorry about the delay. So basically we have a big, grey square, which should actually be green. The way to get around this is to set shadow shading on number 1 like that. So type in set shadow shading on 1 and then recompile. And as you can see, it's now a proper green colour. I'm not sure why that is, but it's just one of those little quirks we're working around. So shadow shading is something I intended to turn on anyway. So by adding that command, it now displays properly. So next we're going to create our boundary or our visual box area that the game is actually going to take place in. So imagine the walls around a tennis court or a fence or something. Now there are two ways of doing this. We could either create 4 boxes, one at the top, one on left and right, and one at the side, and that will create a nice hollow area in the middle. However, it's a bit of a pain to line up, and the commands are a pain to type in. The easy way of doing this, or the easier way, is to perform a CSG. I've forgotten what it means now. Hang on a sec. Oh, sorry about that, just had to look it up in the book. Constructive Solid Geometry is what it stands for. So we're going to be using a CSG command in order to basically take one box and subtract it from another, creating a nice hollow in the middle. So I'll show you what I mean now. If we type in make object box 2, 805, 603, 75, and then we create a second box, make object box 3. We're going to give it the dimensions of 790, 593, 100. Now you'll notice that the width and length of the object is smaller in box 3 than it is in box 2, but it is deeper in both directions, so it's basically carving a hole through the middle of the box. At the moment they're just overlaying each other, but to carve a hole, what you do is you type in perform CSG difference, and we're just going to type in the object number 2, 3, so we're subtracting 3 from 2, and then we're going to type in delete object 3, and if we compile that now, we now have this nice boundary area around our plane. So these are the walls that our ball is going to be bouncing off, and this, I think you'll agree, is a lot easier than simply typing in 4 box statements. Well, actually no, it's not easy, because I'm going to be doing that anyway for collision detection. However, it is prettier and easier to texture if you have 4 boxes positioned and rotated and all sorts of things, and the textures won't meet up properly and you get all sorts of problems like that. But if you use this method and just put this in for a visual wall, and then set up hidden collision boxes, which are just 3D objects that are hidden, and use those to detect the collision, then it's a perfectly valid way of doing it, and it makes it look a little, it's just easier to make it look prettier. So we can close that and we can proceed on to the next section. Remember, always save your project whenever you can. And what we're going to do now is type in the boundaries. So I won't hide the objects initially. I will type those in the second time, and I'll show you what I mean. So this is the original method I used to bounce the ball around, and I actually had these visible and that as well. But I later discovered the CSG looked prettier. So we're going to start off with the top boundary. So this is the top section of the wall. So if we compile that again quickly. So what we're basically going to do is create the top area first, then we're going to create the boundary, then we're going to create the player side, and then we're going to create the AI side. So this is where the TB, BB, player B and AI B comes in. So we've got 4 different surfaces that our ball needs to react to when we create it. So we're going to type in tb.id, because we're going to be using this ID in collision detection. We need to enter it into system memory so we can easily reference it. We could just reference it as 3, but tb.id is easier to remember, or at least it is for me. And then we can type in make object box tb.id, 805, 10, 25, and position object. Whoops. sorry, position object, my mind's gone blank, tb.id, comma 0, comma 290, comma minus 25. So if we then compile that, now you see there's a second wall, so it's actually slightly further in. That's because when the ball impacts onto an object, it tends to go into the centre, so you end up having half the ball. So if I move the collision box out slightly, that creates a better effect, I think. It's not perfect, but it's a better effect. So when the ball impacts onto the wall, it looks like it's actually bouncing off the wall rather than submerging into the wall halfway, then bouncing off again, which is a problem I've often found when not doing it this way. So anyway, this is the top boundary area. Now what I'm basically going to do is close that, and I'm going to hide it. So if we type in tb, hide object, whoops, did type that in right, tb.id, and basically what this then means is that this object is now hidden. It exists in 3D space, and it will be treated as a 3D object when it comes to collision. However, it is now invisible. So we've now got that invisible and boundary area, well, invisible, and it will look like it's bouncing off the wall, even though it isn't. It's a bit of visual trickery, but this is a nicer way of setting it up, I find. So now we're going to move on to the next section, which is we're going to create the bottom boundary. So bb.id equals 4. Same reasoning as before. Make object box bb.id, comma 805, comma 10, comma 25. And then we're going to type in position object bb.id 0, comma minus 290, which you'll notice that that's plus and this is minus. This goes back to what I was saying before. The middle of the screen is 0, 0, 0. So if you want to go below the middle of the screen, you need to go into negative numbers. If you want to go into the top of the screen, you need to go into positive numbers. Same for left and right. If you're heading towards the AI, which is going to be on the left-hand side, then you need to go into negative numbers. And if you're heading towards the player side, then you need to go into positive numbers. And dead center of the screen is going to be 0, 0, 0. So minus 290 and negative 25. And just check that's right. Yep. And we're also going to type in hide object there as well. But again, if you compile this and have a quick look. Oh, I've made a bit of a mistake there. I forgot a comma. Again, we've got this second boundary down here, considerably way away from the wall, as you can see, but again, that creates the illusion I'm looking for. And this is basically the boundary area that is going to be hitting every time the ball moves onto the bottom area. That's what it's actually going to be hitting, even though you can't actually see it. So hide object bb.id, and next we need to proceed onto the AI boundary. Now this is the left hand side, as I said. Hopefully I know my left from my right. So AIB.id equals 5. Make object box AIB.id, comma 25, comma 603, comma 25, and position object AIB.id, comma minus 400, comma 0, comma minus 25. And again, we'll have a quick look at that to make sure it's positioned correctly. So again, this wall is considerably thicker now, so again, it's away from the wall itself. It provides a nice surface area for the ball to bounce off, though actually it won't be bouncing off this wall. Basically what will happen is when the ball hits this particular wall, it will then subtract a life from the AI side and reset the scene so the ball returns to the middle of the screen. So it doesn't actually need to I don't actually need to worry about sinking into the bottom of the wall. I suppose I would actually, thinking about it, because then it will pause and the ball will be halfway through the wall. It might look a bit odd. So again, having that little bit of clearance away from the wall itself gives a nice illusion of the ball bouncing off it or pausing just on it, rather than creating the illusion of the ball actually sinking into the wall. So again, we'll hide that. So hide object. AIB.id, and we'll proceed on to the final one, which is going to be PLYRB.id, and I might copy that because it's a bit longer to type out, and we're going to give it the number of 6. You can see what I'm doing with the ID numbers here. We started off with 1 for the ground plane. We've got 2 for the boundary box. I then deleted object 3. I then proceeded to assign 3 to TB.id, then 4 to BB, 5 to AIB, and 6 to player B. And we're then going to do the same again. So make object box player.id 25, 603, 25, and need a small a there. Well, I don't need it, but it looks neater. Position object playerb.id 400. It says typing in every other number, 0, minus 25. And again, we'll compile to make sure visually that it's in the right place. And again, the wall over here, the wall over here is considerably thicker than the wall over there. So we know that that is working as well. So we can then type in the hide object command. Just notice there's a big B there as well. Hide object player.id. And that basically sets up our 4 boundaries, our 4 reactive boundaries that our ball can actually impact on. Now, the top boundary and bottom boundary, we simply want it to bounce off those boundaries. We don't want any penalty to the player or the AI, whereas if it hits the AI B or player B, then the lives need to be reduced and we need to reset the scene ready for the next set. So next we're going to create a middle line down the middle of the field. We don't actually need to do this, but I think it looks a bit prettier. So make object plane 7, 5, 4, sorry, 580 or 590, whatever, 1. So we're literally making a line here by using a plane. In the 2D version of this tutorial, I just used the line command, but for this one, we'll stick with the 3D objects and we'll create a nice plane. And that basically creates a little bit of a plane down the middle. Now, I don't actually want it touching each side because on a real tennis court, you actually do have a little bit of a boundary between the wall. I know it's not accurate, but it will do for me. You can also notice that the shading around the walls and stuff, so because I've positioned the spotlight in the position I did, you get this slight shading effect rather than having it glaring down and just illuminating everything. So again, this gives it a little bit more, this gives it a bigger sense of depth, and it just makes it a little bit more attractive. And this is what I found as I was experimenting with different setups and things. You can also see, so because the light is positioned somewhere sort of down there, you can see that the light is fading all the way up this line, so it's slightly grey there and slightly bright there, so you've got a bit of a gradient going on there. And of course it's the same on the walls and things. So I think it looks a bit prettier. Other people may not agree, and you're welcome to change it as you see fit. Next we're going to create the object we all need, which is ball.id equals 8. And of course, once we've done that, we then need to create a sphere. So make object sphere ball.id, 20. Position object ball.id, 0, 0, -30. Now, people might ask, why don't I just put in... Whoops, I didn't spell that right. People might ask, why don't I simply type in the object ID? Even if I put ball there, the object ID there surely would be quicker to type in. And yes, it's true, I could just type in 8 and it would be a lot easier to type in, a lot quicker. However, should I ever change ball.id because I add additional features into this area, that means I'll need to change every single 8 in the program as well. And rather than do that, there's no need to. All I've got to do is change ball.id in future and it will all automatically up. Now what we're actually going to do is populate the data in the program as well at the same time. Now I've positioned the object as 0, 0, -30. Again, if I want to update the data at any time, all I want to be able to do is just change this positional object data here, and that will be it. So the easiest way of doing that is to type in ball.x equals object position x, open bracket, ball.id, close bracket, and this basically populates the ball.x data with the current location of the ball. So if I want to change that value to 10 or whatever, then ball will automatically change. Now I could also do it the other way around, set up ball.x first and then type it all into the command there, but I find it's a bit easier just to type it directly into the command as a personal preference. Now a way of speeding up this process is to simply copy and paste and paste and paste again. Now I know they both say the same thing, so what we're going to do is we're going to update this to Y and Z, and then we're going to go over to here and we're going to adjust that to Z and Y, and of course ball ID will stay the same. I'll just check that it is true on my other screen. ZY, yep, that's right. So we've now populated our program data with ball.x, ball.y and ball.z. Again, I could do it the other way around, but it doesn't make much difference really. Now I want to set object collision to spheres, and this basically gives a nicer collision feel, so you can hit the edge of the ball and stuff as well, rather than having a big box floating around it. So ball.id, this is setting up special collision data for that particular object. Everything else will be defaulting to boxes. Next we're going to set up the AI pad. So this is going to be the pad that the AI of the computer controls. So AI.id equals 9. I suppose before I do that I really should check that that's working correctly, so I'll just compile to make sure. It's a good idea to compile after all these bits. So yeah, we got the ball in the middle of the field there. The other thing I just thought of is I'll just quickly compile that again, show you what I'm talking about. There's no shadow by the ball. It'll appear in a moment. So all we got there is a ball that's quite well shaded from the direction of the light, but there's no shadow on the field or anything. And one of the things that makes this a little bit more attractive than the 2D versions, apart from the rubbishy sprites, is being able to cast shadows on the field. Now I've tested this with an Intel, which is what I'm recording on now actually. It's an Intel 4500 HDMA, I think that's what it is, yeah, HDMA graphics card, so that handles shading on such a simple scene quite happily. So if we type in the extra command after that, we're going to type in set shadow shading on ball.id, and then we simply compile again, and what we should see is a shadow cast onto the field itself. So we need to set these objects up. There we go. So now as the ball travels across the field, you'll get shadowing on all the objects and things. So that's what we want, to make it a little bit prettier and to make it stand out a lot more from the 2D versions. And of course we don't have to worry about ghosting sprites or drawing second shadows manually or anything. It's literally calculated by the position of the light, and it's a lot easier in 3D than if we try to produce the same effect in 2D. So we'll close that, and then we'll proceed onto the AI, which I should have done just now. So AI ID equals 9, make object box AI.id 10, 60, 12.5. So yep, those are the dimensions. Yep, those are what I set up originally. Not sure why I put 12.5, but it's probably a visual thing. You can experiment with the size, see if I was wrong. So position object AI.id, minus 350, 0, minus 30. Now, in the same way we did for our ball.id, we're actually going to do the same thing for our AI pad. So I'm going to paste that in there, and I'm going to replace these balls with AI. And I'm going to adjust ball there to AI as well. Probably not a lot quicker, but it's a little bit quicker. And of course we're going to set shadow shading on that as well. So if we quickly compile that, I'll just check that I've got that right. Yes, that's right. So we quickly compile. So we've now got our pad here. Now again, you'll notice there's shading there, but there isn't shading on the pad. It's not casting a shadow. So again, if we type in set shadow shading on, let's say that 5 times fast, AI.id, we'll compile that, and with any luck we should have a nice shadow on the wall as well. There we go. So we now got a shadow travelling up and down the field with the object as well. So we got our ball and we got our AI pad, and that's what we need to do for that one. And we need to do the same thing for player as well, rather than typing all this out again, because I think it's more or less the same code. I will just check on my screen over here. So player Z, player Y. Yep, it's just some different positional data. So we're going to copy this. In fact, we could cheat a little bit, and we could go Notepad. We could paste it in there, and then we could go Edit, Replace AI, and we could type in PLYR instead. Replace all, and that's an awful lot quicker, isn't it? And we can then copy that, put it back in here. And we need to adjust the positional data. All we need to do is make negative 350 positive 350, because it's going the other direction. And other than that, it's absolutely identical. So that's a little bit of a trick to help save you some typing. Oh, and also remember to update the ID, otherwise you're going to be in trouble. So to make sure I've done that correctly, excuse me, my voice is going. So again, we've got our pad there, we've got our player pad there. It's been populated with data, and we've done the same thing for the ball as well, and it's all properly shadow shaded. So that's quite nice. And I think, yep, that was it. That's basically it for the make objects area. So now we've done that, we need to save it, and we've tested it so we know it's working. Remember to test regularly, otherwise you will be caught out, and no one likes that. And then we can proceed on to the next function. So now that we've done the make objects function, we need to proceed onto the set reset function. And of course we're going to go in here and we're going to enable that, though it won't be blue until we've actually created the function. And of course we're going to start with the function, function isn't right, function set reset. Now what this basically does is reset the set the game is playing. So in tennis terms, it's game set and match, isn't it? So basically, to set reset, probably not the right terminology, but I know what it meant. What we need to do is reset a series of data and set up some flags, and we press return, and that magically creates the end function. And we're going to type in ball.flag x equals rnd1, and we can copy that and change that to flag y. And what this basically does is determine the direction in which the ball is travelling. So I can't remember which direction it is, but 0 will indicate going up or down, and 1 will be the opposite to that. And it's the same for x and y, so exactly the same actually as the original 2D tutorial. So the basic logic is the same, even if the 3D graphics are not. And we're going to set a random speed, so ball.xSpeed equals rnd open bracket, equals 2.5, add rnd open bracket 15 close bracket divided by 10, and that's it. So basically what we're doing is we're adding a random amount in the value of anywhere between 0 to 1.5. That's what divided by 10 is all about. So basically it will have an initial starting velocity across the x-axis, which is left and right, of anywhere between 2.5 to my math is gone. So 3 to anywhere between 2.5 and 4. So not much of a variation, you might think, but it is quite significant when you're dealing with updating the screen 60 times a second. So ball y speed equals 1 plus rnd open bracket 20 close bracket, I've forgotten the external brackets, so divide by 10, and we need external brackets for that as well. And what this basically does is create a shallower or deeper angle. There's a bigger difference between the two because x is up and down. X is left and right and y is up and down. So the faster it is going in the x direction and the slower it is in the y direction, then the shallower the angle is going to be when it bounces off the walls. However, the deeper the y, or the faster y is going, then the bigger the angles are going to be as well. Now you don't want them too big initially, otherwise it's going to be quite difficult to play the game. So after experimentation I found this was best. Again, you can play around with the settings and see what you like. So ball.x equals 0, ball.y equals 0, and ball.z equals minus 30. Now you may recognize this, and it pretty much does invalidate my having set it up in the previous function, as it happens directly after it, but never mind. Code can always be a bit optimized. Even after you've tested it a few times, you always spot these little improvements you can make. And so player.x equals 350, player dot y equals 0, and player dot x z rather equals minus 30. So again, we're resetting the position of the pads to where they were originally. AI.x equals minus 330, the exact opposite of player. Sorry. AI.y equals 0, and AI.z equals minus 30. Hopefully you're seeing what I'm doing here, and what that basically does is reset all the data. So next time the balls are repositioned and drawn on the screen, this is the data it's going to default to. So basically this means anytime a set starts, the ball can be flying in any direction within a set limit of speeds, but it basically gives the idea, it gives the player no idea which direction the ball is going towards. It might head towards them straight away quite fast. It might head towards the AI quite fast. So, it means that you're not following the same old pattern every time you restart the game. So it makes it a little bit more interesting. What we basically need to do now is test. And to be honest, you won't really see anything on screen, so we'll just compile the program, and if it doesn't throw up any errors, then we can assume that it's all typed in correctly, and hopefully if there's any obvious mistakes I'll notice them later. So that program started without any major upsets, so that's good. Oh, the other benefit of using 3D in this way that I didn't mention before that I meant to, is that with the 2D version of this tutorial, you had a fixed pixel amount. You had to adjust everything if you wanted to adjust the pixels, whereas with this version, if you adjust the resolution, so I could put it a nice 800 by 600, it would all look the same, and the game logic will function in exactly the same way as well. So this is very useful when it comes to being able to resize the screen without having to do a massive rewrite of the code, which is what you have to do with many of the 2D games, especially when it comes to sprites and things, because they all tend to be rendered at the particular resolution. So next we need to proceed on to the next function, which will be ball. So we need to set up the ball function. So we've now uncommented the ball function, and we're going to proceed to type that into our program. So I'm just going to scroll down my code over here again. So we type in function ball, open bracket, close bracket, and of course end function appears again as if by magic. And we're going to start off with our first sorry, hang on a sec. Right, so we're going to start off our ball with if object collision open bracket ball.id comma ai.id open bracket equals 1, and then we need to go then ball equals flag x, sorry, ball.flag x equals 0. So what this is basically doing is it's saying that if you've hit the AI pad, then you need to reverse the direction of the x-axis of the ball, so it bounces off the pad in the other direction. So 0 is going to be towards the player, and 1 is going to be towards the AI pad. So just put a bit more space down there. And we're going to type in another one, if object collision between ball.id and player.id equals 1. Then again, we want to send the ball in the other direction. So ball.flag x equals 1. Okay. So I'm just working the logic out in my head as I go along. You can always work this stuff out when you write it, but afterwards you have to work it out again. Then we need to go if object collision open bracket ball.id comma player b.id. So this is the boundary now. So if ball.id and player b.id equals 1, then whoops. So a bit of an odd thing on the IDE here, but never mind. Right. So we now want to set that ball flag to 2. So ball flag x equals 2, and this sets up a new condition then. So basically, if the ball hits the player boundary, then we want to subtract a life, and we want to check that the lives are not below 0, and then we want to reset the scene if the lives are above 0. So if you've got 1 or 2 lives or 3 lives or whatever, then you want to reset the match and serve the ball again. Whereas if you don't, sorry. Basically what happens is when it's set to 2, and that means the ball has hit the boundary behind the player's pad. This basically means that when the 2 condition is initiated, that a life is subtracted, and then if those lives are below 0, the game is ended with a lose message. If it's not, then the set reset command is produced, and the ball is reserved, and you continue playing, which is what I should have said in the first place. So and the same thing goes for if it hits the boundary behind the II pad. So if object collision open bracket, I must have mistyped that. I missed out an I. Right, so if object collision ball.id and comma aib.id open bracket equals 1, then basically this means a collision between the ball and the AI boundary has occurred. So we need to set the ball.flag x to the status of 3. Now we're going to deal with these conditions. So we're going to select ball.flag x, and we're going to set up a number of conditions now using case statements. So we're going to type in case 0, so this will be the first one here. So case 0, ball and AI, is going to be inc ball.x comma ball.xspeed. So basically ball.x is then increased by the value of x speed, and basically if the program started with a high x speed, then the match is going to be quite shorter. If it started with a low x speed, then the match is going to last longer. And again, this creates a variable, almost organic feel to the game that prevents it from being too static. So you don't know exactly what it's going to be unless you know the numbers and you work it out mathematically. Otherwise you're just watching the ball and you see what speed it is, and it's going to be different each time. So it creates a little bit of a mix-up of the game. So so inc ball.x ball.x speed. I'm sorry, I'm talking absolute rubbish there. Ball.x is a location. So ball.xSpeed is basically moving the ball on the x-axis. So so all that command is actually doing is moving the ball along. So whoops, I don't know what I'm talking about. Okay, if ball.flag equals 1, then inc ball.xSpeed, 0.1, and ball.flag equals 0. Then, oh, there's an end if there already, and then end if and end case. So to recap, what we're basically doing is if case 0 is in play, which is the collision between ball ID and player ID, then we basically want to inc ball.x by ball.xSpeed, and that basically changes the position by the value of x speed. Then if ball flag equals 1, increase ball.xSpeed by 0.1 and ball flag equals 0. And you should always keep the variables the same. So I typed that in wrong. I've just said that. So don't get the flag.x confused with ball.flag. That's a completely different piece of logic. So next we're going to proceed on to case 2. Then dec, which is decrease, of course. Decrease. No, sorry, I need to go on to case 1. Sorry, it's getting rather tired. I've been doing this rather long time. Right, case 1. Then we need to dec ball.x, ball .x speed. That's correct. And then we need another logic statement. If ball dot flag equals 0, so exact opposite of the last one, then inc ball dot x speed by 0.1. So we're doing exactly the same thing we did before. We're speeding the ball up slightly, and then ball dot flag equals 1, and we need to bring the end if there and end case. So we've basically done the exact reverse on case 1 that we did on case 0. And then we're going to type in case 2. Now, if case 2 occurs, then the ball has hit the wall behind the player, which basically means we need to decrease the player lives. So dec plyr dot lives, and this will decrease it by the value of 1, which is default for dec. And if player dot lives is less than 0, so minus or whatever, then we need to put some text on the screen. So center text screen width half. This basically means that we can change the resolution without having to worry about replacing our screen all the time, our text rather. Screen height, open bracket, close bracket, divided by 2. Obviously we divided by 2, so it goes in the middle of the screen. And we're going to get some text. You lose. Press any key to play again. And then we're going to sync, so it actually displays on the screen. And we're going to wait key. So the user can either respond by doing that or press escape to exit the game. And we're going to do a full reset. So full reset, which isn't a command we've actually created yet, which we will do later on. and else. We need to provide an else statement as well, and we need to bring the if statement, and if in line as well, and of course we need end case as well. Oops, yeah, I'm getting a bit premature here, aren't I? I haven't touched on the rest. Right, sorry. Case 2, blah blah blah. Sync wait key full reset. Then we want to center text screen width open bracket divided by half, screen height open bracket close bracket divided by half. This positions the text quite nicely, and we need to give the condition or text of you lose a life. So basically, if the player's lives is below 0, then the game's basically over and you need to restart. You've lost. I need to put text there, sorry. If it's above 0 or just else, or if it's any other condition, then we just subtract a life. So, which we've already done at the beginning. What we need to do then is give a message, so sync and wait 2000. So that's 2 seconds. I'll copy that center screen text again, save myself a bit of effort. And get ready. Sync, so it displays on the screen again. I'm just scrolling my source code up on the other screen. And of course go. So sync, we also wait another 1000. So we waited a whole 3 seconds so far. And center text, go. And what do we need to do then? I need to set, reset. This returns the data to 0 and picks a random direction for the ball. And once we've done that, we need to, sorry, I should have put sync and wait 500, half a second, and then reset and it starts. So it gives you time to read the messages. So I'll give you 2 seconds, then 1 second, then half a second, and the game restarts, which I find is plenty. It's probably a bit long if anything. So there we go. So we now end that with end if, and we need to end the case as well. So end case. And oh no, I've made another omission there, sorry. After the end if, we type in dec ball.x, comma ball.xspeed. And we set ball flag x to equal 1. Yeah. And then we need to set up case 2. So there's quite a lot of logic going on in the background here. And that is in case, yep. So then we set up case 3. So case 3, this is a ball behind the AI player. So in the condition of case 3, we then decrease the AI.lives value. If AI.lives is less than 0, then basically the computer's lost. So center text screen width. In fact, I can copy all that. We're going to give the message you win, exclamation mark, press any key to play again. Sync wait key full reset. Then we need an else condition, so if it's anything higher than 0, then center text, and we want the message AI lost a life, exclamation mark, sync, and wait 2000, and get ready, wait 1000. Whoops, I need to sync first. Center text again. Scrolling down my source code again. And go! Exclamation mark. Probably could have done that off the top of my head, but I like to make sure. Sync, wait 500, set, reset, and end if belongs there. And of course you also need an end case. Now we also need to set up a case, a default, just in case the value goes outside the range unexpectedly. It shouldn't be possible to happen, but if you've typed in something wrong, as I often do, then it's quite useful. So case default, and we basically want to put the text, centered text, error ball dot flag x is out of range. So a bit of a generic error message that with any luck you won't ever see. And of course we need to sync, wait key, and end the program if that's the case. So end case. And that's basically our primary logic, and so that's our primary logic for the x-axis. So quite a lot to write there, quite a lot to follow as well. Next we need to do the y-axis detection, so we've only done x so far. Which luckily is considerably shorter. So if object collision ball.id equals 1, then ball.yspeed equals ball.yspeed minus open bracket ball.yspeed times 2. And what we're basically doing is subtracting the value of ball from yspeed from ball from yspeed multiplied by 2. So this is effectively reversing it. And then end if. If object collision ball.id comma bb.id, which is the bottom boundary, equals 1, then ball.yspeed equals abs ball.yspeed close bracket. And if ABS basically takes a negative number and turns it into a positive number, so we don't need to do all that math a second time. Then inc ball.yspeed comma ball.yspeed, so increasing the speed by speed again. Sorry, ball.y by ball.yspeed, so this is the movement, sorry. And then we need to position object ball.id comma ball.x comma ball.y, comma ball.z. And we need to get rid of that extra end if, because I sometimes forget it creates them. So either that or I've got one that's missing. So we need to test this code. So function full reset, because that doesn't exist yet. And I've just noticed that I've not got an end select. So you need to do an end select after end case. So end select. I've also made a minor mistake there. So we need to type in ball.id and tb.id because that's the top boundary. So I forgot that. So now we need to actually test that the ball moves and that it triggers. So we're going to click the play button. As you can see, the ball is moving. It's moving very slowly because the software doesn't really pick up the ball. So I've lost a life there. Press any key, go, and it heads off in another direction. I should probably fraps this rather than use my screen capture. So it's detecting the loss of life quite happily. Let's go in the same direction again. And in a completely different direction. So it randomizes the speed and directions quite helpfully, and it bounces off the top boundary, and as soon as it hits the back boundary, it works. Now we won't know if it's working hitting the player or AI pads yet because we haven't actually programmed that. But hopefully when it comes to actually moving the controls, it's going to work fine. So I could adjust the program. What's going on there? You win, press any... Oh, that's because the full reset hasn't been typed in yet. So we should really do that as well. So we're going to type in full reset now, and ball dot flag x equals R&D open bracket close bracket 1 ball dot flag y equals R&D open bracket 1 close bracket, excuse me, ball dot x speed equals 3. Ball dot y speed equals R&D open bracket 30 close bracket slash 10 plus 0.5, and of course this adjusts the speed, and ball dot x equals 0, ball dot y equals 0, ball dot z equals minus 30, and now we position the player, so PLYR equals, sorry, PLYR dot x equals 350, PLYR equals y equals 0, PLYR dot z equals minus, is that right? Minus 30, yeah. Oh, it's going up the z-axis. I had to think about that one for a sec. AI dot x equals minus 330, AI dot y equals 0, and AI dot z equals minus 30. I think that's all typed in right. AI dot lives equals 3, and player dot lives equals 3 as well. So we're doing a full reset on absolutely everything. So basically it's the same as the other reset, I believe. And the only difference is you don't have the player lives and AI lives as well, and also the Y speed is slightly different. So we'll save that, and with any luck, when we test it now and it fails, I won't make you sit through it again. I'll just pause the video while it loops. So yes, it reset quite happily, so that wasn't the problem. Excuse me, coughing away here. So next we're going to proceed on to the player control, which would be quite useful. So we uncommented that, and we're going to go into that function. Once I find it on my little screen over here, there we go. So we're going to type in function player. Oh no, it's PLY on it. PYR. PLYR. PLYR control, that's right. Quite important to get the spellings right, and I am quite bad at spelling, I have to admit. If up key, open bracket, close bracket equals 1, then inc player dot y comma 5. If object collision player dot id comma tb dot id equals 1, then dec player dot y comma 5. So basically what we're saying here is if the player pad hits the top boundary, then we reverse the increase by 5 and reset it to as it was before. So rather than with the 2D version, which basically set the limit by a number of pixels, what we're basically doing here is saying is if these objects collide, then reset the data to, by 5 units, and it will appear as if it hadn't. So up key equals 1, player.y5, dec, right, so that limits the player. If object collision open bracket player dot id, shouldn't put a space there really, sorry, don't know why I started putting spaces there, comma ball dot id. So if there's a player and player pad and ball hit, then if that equals 1, which is the state for 2, then increase the speed of the ball across the y-axis by 0.25. This will of course adjust the angle. And end if. And we need another end if there as well. And now we do the down key. So if and down key, open bracket, close bracket equals 1, then decrease the player, player.y by 5. So this goes down. If object collision player dot id comma bb dot id equals 1, again we're going to limit the movement. So sorry, there's an end. There's a than equals it than or then inc player dot y by 5. So doing exactly the same thing as we did above, we're just reversing it. So not sure the space is different there, but never mind, doesn't matter. And next we need to, if there's a collision between the balls, so same again, if object collision player ID, comma, BB, sorry, ball.id equals 1, then inc player sorry, have I got that right? No, there's no then. I use a combination of two. I don't know why I've done that, but I have. Never mind. Ball.y speed and deck ball.y speed by 0.25 and if Now, if you're wondering why I'm increasing and decreasing the y speed, it's basically under the following condition. If you're holding down the up key as you hit the ball, then we want to increase if you're holding the up key as you hit the ball, then you want to increase the amount of y. The speed of the y, which increases the angle. So basically, as you're holding down the up key, and this only happens when you're holding down the up key, and if you hit the ball at the same time, then you're actually increasing the angle of the ball. And if you do the same with the down key, but you hit the ball as you're holding down the down key, then it decreases that angle. And what this basically means is that you can adjust the trajectory of the ball simply by holding down the up key while the ball impacts, or holding down the down key while the ball impacts. And what this basically means is you have some degree of control over the angle in the game, which is an advantage that the AI does not have. So you've got the advantage that you can adjust the angle by increasing it until you get that shot you want, which gives the player more control over the ball. But it only happens if you hold down the down key or the up key at the same time. You also have to bear in mind which direction the ball is going, because if it's heading downwards, then holding the down key at the same time will basically put it into negative numbers. So because it's already in a negative number, that basically means it's increasing the angle anyway. But if the ball is heading down and you push the up key as the ball is heading down, it's actually going to decrease the angle. So again, this gives a little bit more control over the ball and allows you to make the shot you want and plan ahead in the game. This, of course, will be useful for two-player games, which is a mode I'll probably add at some point. Then we want to position object player dot id, comma player dot x, comma player dot y, comma player dot z, and we want to end a function, which I think I've already done. I've got an extra end if. Oh no, I don't know where that's come from, but I have a habit of typing it in. So hopefully that's all that is. So now, with a bit of luck, we should be able to control the ball. So I'll do a quick compile, and there's my first typing error. I'm going to do another compile. And now, yes, I can in fact move to intercept the ball, and it does in fact bounce off. So I can now, and holding the keys down, yep, I cannot go beyond the boundaries. So that is everything the player could possibly want from a ball. Sorry, from a pad. So I can now intercept and move the ball. So I'm completely cheating now. The AI isn't enabled, and I can now win every single time. Oh, he's actually going to hit the pad there. No, almost. That would have been quite amusing if he did. But there we go. So we now have movement on our pad and proof that the system does in fact work. So another moment off our checklist, or another function rather. Now we need to go on to AI control. So scroll down on my text again. And save that. And now we're going to create a new function, which we need to enable here as well. I should probably have done the... I don't know why that's not showing up as blue. Oh well, we know it works, so it doesn't matter. So anyway, we've enabled the AI function. Now we need to create one. So function AI control. So now we need to type in if ball.x is greater than AI.trigger, then we function, then we basically execute the code. So this is basically what I was talking about, the AI zone. It's just this simple line of code. But basically, if ball.x exceeds the value of AI.trigger, which in this case is 0, so that means if it's going into the player half of the screen, then this whole AI code, sorry, if it's going into the player half of the screen, then this AI code will not activate. Whereas if it goes into the AI's half of the screen, then it gives it that amount of space to actually respond to the ball. And it does move quite quickly, so this will be quite an accurate AI. It'll be quite lucky to beat it. So you really want to go into negative numbers if you want to make it a nice easy one to beat. So now that we've done that, we need to type in for x equals 125. Now the reason I'm doing this is because the player pad moves in 5 units at a time. Now we could do that as well, but it means the pad jumps around quite a lot and it's quite unattractive. So what we want to do is track it by 5 units. Sorry, by 1 unit at a time, but repeat the process 5 times. That way it will match and produce a nice smooth movement along with the ball, rather than a rather jagged performance, which works well, but it doesn't look that attractive. So this is just a little bit of eye candy. I have to admit, I'm growing less fond of it, putting necks in for me and stuff. Right, for x equals 1 to 5, then if AI.y is greater than ball.y, so it's basically taking the ball position, the AI position, and saying if it's greater, then we need to decrease the AI value. So dec AI.y, and this basically moves it down a level towards the ball. If object collision AI.id, bb.id, so bottom boundary, equals 1, then inc AI.y. So we basically want to increase it by 1 again, and again this prevents it from going beyond the boundaries of the actual game, so it gives the illusion of the wall being physical and impeding its progress. I don't need an extra tab there, never mind. So once we've done that, we need to go dec, then if object collision, and then that's straight to end if. I think. Yes. There's a second end if there. And once we've hit end if, we basically want to make some more space and then start the next section of logic. So we've done the greater than statement. Now we need to do the less than. So if ai.y is less than a ball.y, then we want to increase ai.y, the position of the pad, and we need to say if object collision open bracket ai.id comma tb.id close bracket equals 1, then dec ai comma y. So again, exact opposite of what we're doing, but then we're doing less than, so that's not surprising. And we need to finish up with an end if, and finish up with the next. So that should be next x for my peace of mind. You don't have to type it in, but I always do. And of course there's a second end if there, which we created originally. All these end ifs. There we go. And we need to finish off by saying position object ai.id comma ai.x comma ai.y comma ai.z, and this ensures that our objects are positioned correctly, because it's all been updated here but it hasn't actually been repositioned. And with any luck we should have a working AI, so we'll see what horrible mistakes I've made this time. Oh, there we go. So as you can see, the pad is tracking the ball very slowly because I'm screen capturing at the same time, and it's continuing to track the ball. However, as soon as it passes the 50% mark into my field, it stops tracking. Now if I deflect the ball back again, as soon as it passes that line, there you go, the pad is now tracking it. And it's quite a smooth motion. I'll do a proper fraps screen capture of this game at the end of the tutorial, so you can see how smooth it actually is. But as you can see, this because if the pad was tracking it all the time, then there's just no chance it will miss. It's just not possible. But as you see, it's constantly updating all the time. So, but it's more or less what a human player does anyway. Not quite as precisely, but there we go. I've got a nice shallow angle there, so there might be a chance of a win. No, it's got it. So 50% or 0 might be a bit too much in itself. Now if I want to adjust that value, I simply need to go into the main program and I need to make this negative 200. That should give me a fair chance of winning. So we make that negative 200, recompile the game. And we'll bounce the ball and see how long it takes. Now you'll see it's going to be well past the line before it starts responding, like that. So what we're basically doing is adjusting the response zone of the ball. Now we could also write in a little bit of code that says once it's hit the pad, until it's hit the player pad, then it's not going to respond as well. But to be honest, I'm a bit lazy, so I haven't done that. But it's certainly a bit of code that can be added. So as you can see, that's basically adjusted it. Now what you could also do is put a randomizing factor into the AI responsiveness. So you could say take 0 and randomize sort of, I don't know, something like 150, and whatever the value is, that's going to be the amount that's subtracted from the AI's responsiveness. So and that would it'll give a slightly less consistent result, which might be a little bit more organic feeling. I haven't actually done this, but it's certainly something that's pretty easy to do. But this is basically the game in action. All we're missing here is a little bit of code that defines how many lives there are. Now, on my original code, the function screen text is full of lines of data that are actually completely unnecessary. They were useful when I was testing the game. Very useful when I was testing the game because I could see all the data on the screen. Because I know this is a working program example, I haven't needed to put it in this time. So, but nevertheless, we're going to put in screen text because that will indicate how many lives there are as well. So we'll uncomment that. We'll go to functions and we'll add the screen text. Whoops, I don't know why I'm typing in end function. Function, screen text, and now I don't need that one, don't need that one. All I need are the last two, so yeah. So center text, open bracket, screen width, close bracket, sorry, open bracket, close bracket, divided by 100 times 0.85. This is my own private system for positioning text on the screen without having to reference the actual resolution of the screen. So what I'm basically doing is dividing the width by 100 and then increasing it to 85% of the screen width. And I find this is quite a useful way of doing it. Screen height. Yeah, sorry, that is right. Screen height. I'm feeling a bit lazy, so I won't type all that in. I'm just going to copy and paste from my other little document over there. So there we go. So basically, the first one is at 15%, the second one's at 85%. You've got AI lives, then string will convert a value into a string, and we simply need to do that. I'll put an A in the yellow there. And that should do the trick. So now when we compile our program, we should have a fully working version of Turbo Table Tennis 3D. So there we go. That's a bit high on the screen really, but never mind. You can adjust that. As you can see, the ball does go over the text, which is quite good. So there we go. We've got a fully working version of Turbo Tennis 3D. I'll let it hit my boundary just to make sure it's working. So I've lost a life. Press any key. And I won't make you sit through the whole test, but this seems to be working as far as I can tell. The numbers decrease, that's all I need to know. And I shall end this tutorial there. I shall provide this source code on my website, which is accessible via www.dcforeman.co.uk. All my other tutorials are nicely organized there as well. I will also post this. I will also upload the source code and project file to that website so you can download it. Some users in the past have had problems typing out source code from the screen. There have been minor mistakes or whatever that's prevented them from carrying on with the compiling properly. So sorry, I'm phasing out. So yeah, I will provide it on my website as a link. I'll provide the link in the description at some point. But this is basically how you make a fully 3D version of Turbo Table Tennis 3D, Pong, to other people. So there you go. I hope you've enjoyed this tutorial. I hope you've learned plenty. Again, if you have problems following this tutorial or you didn't understand any of the concepts, please go get my DVD. 7 hours worth of tutorials there will give you a good explanation of what's going on and how to use 3D objects and all that kind of stuff. So this is specialized. That one's very generalized to providing as much information to cover as your bases as possible, and it's done in more or less the same sort of style. So if you enjoyed this tutorial, please comment, rate. If you have any tutorials of your own, please let me know. I'll be happy to link them into the system as a video response, obviously, and basically have a good Christmas. So I hope you've enjoyed it. Ta-da.